Hello everyone. In this lesson, I'll complete solving the exercises of lesson 3.3 implicit differentiation. We reach number 23. The graph on the right is the graph of the equation y power 4 equal y power 2 minus x power 2. Find the slope at these 2 points. To find the slope, first we find y prime by using implicit differentiation. Differentiate both sides. 4y power 3 y prime equal to 2y y prime minus 2x. Then 4y power 3 y prime minus 2y y prime equal to negative 2x. Then y prime factorized by y prime, 3y power 3 minus 2y equal to negative 2x. Then y prime equal to negative 2x over 3y power 3, 4 y power 3 minus 2y equal to negative 2x factorized by 2y power 3 minus y. Reduce 2 with 2 equal to negative x over 2y power 3 minus y. At the point square root 3 over 4 and half, replace every x with square root 3 over 4 and every y with a half. Then y prime equal to negative square root 3 over 4 over 2 a half cube minus half equal to negative square root over 4 2 over 8 minus 1 over 2 equal to negative square root 4 over 3 over 4 1 over 4 minus 1 over 2 equal to negative square root 3 over 4 4 common denominator 1 minus 2 4 with 4 negative square root 3 over 1 minus 2 minus 1 equal square root 3. For the point square root 3 over 4 with square root 3 over 2, replace every x with square root 3 over 4 and every y with square root 3 over 2. Then y prime equal to negative square root 3 over 4 2 times square root 3 over 2 power 3 minus square root 3 over 2 equal to negative square root 3 over 4 square root 3 times square root 3 times square root 3 is 3 square root 3 over 8 times 2 minus square root 3 over 2 equal to square root 3 over 4 negative. Reduce 8 with 2 3 square root 3 over 4 minus square root 3 over 2 equal to common denominator 4 3 square root 3 minus 2 square root 3 and for the numerator negative square root 3 over 4. Reduce 4 with 4 equal to negative square root 3 over 3 square root 3 minus 2 square root 3 square root 3 equal to negative 1. Question number 24. Illustrate the difference between implicit and explicit differentiation. The implicit differentiation, we use it when we cannot write y in terms of x. We cannot set right in the side and other terms in the other side, or it is not easy. Then we use implicit differentiation. Explicit differentiation, it is used when we can set y as a term of x. Like, for example, y equal 1 over 2x power 3 plus 1. This function, we can use with it explicit differentiation. But if we have x y power 2 minus tan y equal 3xy, we cannot set y in the side and the other terms in the other side. So we use implicit differentiation with this function. Write the step of implicit differentiation. The steps, we have 4 steps for the implicit differentiation. The first step, differentiate both sides with respect to x. The second step, set the term with y prime in one side. The third step, factorize the term with y prime by y prime. The fourth step, solve the equation for y prime. Question number 26 and 27. These two graphs is for the function f and its first derivative and second derivative. Determine which graph is for the function and which graph is for the first derivative and which one is for the third derivative. For this graph, it is easy to see that this graph is for the function f, since it is for a polynomial of degree 3, and this one is for its first derivative, since it is for quadratic function, and this one is linear function, is the second derivative of the quadratic, the first derivative of the is the second derivative of the function f, since it is linear function. Also, if we see here the function, the function has a horizontal tangent line at -2, then when x is 0, the function has horizontal tangent line, then its derivative is intersect with x-axis at 0. Also, as you see, the function is increasing everywhere from -infinity to +infinity, and its derivative, it is over x-axis from -infinity to +infinity. For the derivative of the first derivative, for the second derivative, as you see this line, from -infinity to 0 is decreasing, then the graph is under x-axis. From 0 to +infinity, the function is increasing and the graph is over x-axis. For the second graph, the quadratic function is for the function f, and the line here is for the derivative, and the horizontal line here is for the second derivative. And as you see, the function has horizontal tangent line at 1, then the first derivative intersect with x-axis at 1, and the function is increasing from -infinity to 1, so the function is under x-axis, and the function is decreasing from -infinity to 1, so the function is under x-axis, and increasing from 1 to +infinity, and the function in this interval is over x-axis. Also, the function here, the line, has a positive slope, therefore this line is over x-axis. For the questions 28 to 30, answer true or false. If y equal x plus 1 times x plus 2 times x plus 3 times x plus 4, then the fifth derivative of this function is 0. It is true, since this function is polynomial of degree 4, 1, 2, 3, 4, then the derivative of polynomial of degree 4 is 0, since the fourth derivative of this function is constant. The first function is 4x power 3, The second function is 12x power 2. The third function is 24x. The fifth function is 24. 1, 2, 3. Sorry, the first derivative is 4x power 3. The second, 12x power 2. The third, 24x. The fourth, 25. And the fifth is 0. If f is an nth degree polynomial, then if the derivative of the order n plus 1 of x is 0, it is also true. The answer is the same of the previous one. The second derivative of a function is the average rate of change of the first derivative. It is true also, since the derivative of any function, its rate of change, it's the average rate of change. It's the other name of the slope. Question number 31, find the first derivative of the function f of x equal x absolute value x. If is f double prime of x defined, let us find the function first. Rewrite the function. Since absolute value x equal x when x greater than or equals 0, negative x when x less than 0, then x times absolute value x equal to x power 2 when x greater than or equal x, negative x power 2 when x less than 0. Since x times x power 2, x times negative x power 2. Then the first derivative, f prime of x equal to 2x and negative 2x when x greater than 0, when x less than 0. If we find the limit when x approaches to 0 from right for 2x equals 0, and from left also negative 2x equals 0, then we can set equal here or here. It is not change the first derivative. For the second derivative, equal to differentiate 2x to differentiate negative 2x when x greater than 0, when x less than 0. Since the derivative, the second derivative from the right equal 2 and from left equal negative 2, then there is the second derivative of this function is not defined. Question number 32. F and h are differentiable, two differentiable functions for all x. Which one of this statement is true? For the first function, if we find the right side, f g prime minus f prime g all derivative, its derivative, then we can set it f g prime derivative of it minus f prime g its derivative equal to, apply the rule of multiplication of two functions, the first one times the derivative of the second one plus the second one times the derivative of the first one, minus, also apply the derivative of multiplication of two functions, the first one times the derivative of the second one, minus plus the second one times the derivative of the first one, equal to f g double prime plus g prime f prime minus f prime g prime minus f double prime g. Negative f prime g prime with positive f prime g prime, then the answer is f g double prime minus f double prime g, but here also is minus, it is true. this statement is true. F g double prime minus f double prime g. Find the first derivative of f times g, then find the second. The first function times the derivative of the second plus the second function times the derivative of the first function. Now differentiate it again. The first function times the derivative of the second plus the second function times the derivative of the first plus the first function times the derivative of the second plus the second times the derivative of the first equal to f g double prime plus f prime g prime plus f prime g prime to f prime g prime plus g f double prime. It is not equal to the left side, so it is false. Question note, definition of L'Hopital rule. If f and g are two differentiable functions and g prime of x not equal to 0 in the neighborhood of c, and if limit f of x over g of x when x approach to z is an indeterminate from 0 over 0 or infinity over infinity, then the limit of f of x over g of x when x approach to c equal to limit f prime of x over g prime of x when x approach to c. Note number 2, L'Hopital rule is used with fractional function only. Question number 33 to 35, find the limit using L'Hopital rule. Limit 2 times x minus 3 over x power 2 minus 9 when x approach to 3. First, we substitute 3 directly. 3 minus 3, 0 times 2, 0 over 3 power 2, 9 over 9 minus 9, 0. Then the answer is 0 over 0. We can use L'Hopital rule. Differentiate both numerator and denominator and find the limit. 2 times x, 2x, differentiate 2x, 2. 2 times negative 3, negative 6 is differentiate derivative 0. X power 2 minus 9, its derivative is 2x. Reduce 2 with 2, substitute every x with a 3. The answer is 1 over 3. Question number 34. Substitute every x with negative 1, 2 times negative 1 square minus negative 1 minus 3 over negative 1 plus 1 equal to 2 plus 1, 3 minus 3, 0 over negative 1 plus 1, 0. Then we use L'Hopital rule. Limit x approach to negative 1, 4. 2x power 2, its derivative 4x, negative x minus 1, negative 3, 0 over 1 equal to 4 times negative 1, negative 4 minus 1 over 1 equal to negative 5. Question number 35. Substitute every x with 3, 3 plus 1, 4, square root 4 minus 2 over 3 minus 3 equal 2 minus 2, 0 over 0. Therefore, differentiate both numerator and denominator to find the limit when x approach to 3. The derivative of this root is 1 over 2 square root x plus 1 minus 0 over 1 equal to 3 plus 1, 4 square root 4, 2 times 2, 4, 1 over 4. Question number 36 to 44, find the limit. Limit x approach to 2 for this function. Let us substitute directly. 2 power 2 minus 2 minus 2 over 2 minus 2. 2 power 2 4 minus 4 0 over 0. Differentiate both numerator and denominator using L'Hopital rule. When x approach to 2, 2x minus 1 over 1 equal to 2 times 2, 4 minus 1, 3 over 1, 3. Question number 37. This limit equal to 4 minus 0, 4, square root 4 minus 2 over 0 equal to 2 minus 2, 0 over 0. Then use L'Hopital rule. Limit x approach 0. Differentiate the root. Negative 2x over 2 square root 4 minus x squared minus 0 over 1. 2 with 2 equal to 0 over 4 minus 0, 4 square root 4, 2 equal 0. Question number 38. Substitute directly every x with 0, e to the 0, 1, minus 1 minus 0 over 0 equal to 1 minus 0, 1, 1 minus 1, 0 over 0. Differentiate both numerator and denominator. Limit x approach to 0, e to the x, its derivative is e to the x minus minus 1 is 0 plus x plus 1 over 1 equal to e to the 0, 1 plus 1 equal 2. Question number 39. Limits ln x power 2 over x power 2 minus 1, x approach to 1. Substitute every x with 1, ln 1 square over 1 square minus 1, ln 1 square is 0, 1 over 1 minus 1, 0. Then use the L'Hopital rule. Limit x approach to 1. Differentiate the numerator 2x over x power 2 and the denominator 2x. Reduce x with x power 2, reduce 2 with 2, then the result will be 1 over x power 2. Equal to limit x approach to 1, 1 over x power 2. 1 over 1 square. The final result is 1. Question number 40. Substitute every x with 0, so we can know if we can use L'Hopital rule or not. Sine a times 0, sine 0, 0 over sine b times 0, 0, sine 0, 0. Therefore, we can use L'Hopital rule. Limit x approach 0. Differentiate sine ax, a cosine ax over sine bx, its derivative is b cosine bx. Substitute every x with 0, cosine 0 is 1, the result is a over b. Question number 41. Substitute every x with infinity, positive infinity, then the behavior is depending on the x with maximum power. Positive infinity power 2, infinity times 3, infinity over infinity power 2 infinity times 2 infinity. Therefore, we use L'Hopital rule. X approach to positive infinity, differentiate the numerator, 6x minus 2 over differentiate denominator for x. Also, we substitute every x with infinity. We see that 6 times infinity infinity over 4 times infinity infinity. We use the L'Hopital rule again. Limit x approach to positive infinity, 6x, 6, 4x, 4 its derivative. The answer is 6 over 4. Reduce 4 with 6 by 2, 3 over 2. Question number 42. Substitute x with infinity, infinity over infinity square, infinity plus 1, infinity square root infinity, infinity. Therefore, we will use L'Hopital rule, x approach to positive infinity. Since x approach to positive infinity, then square root x equal to x. Now we can substitute x with square root x power 2. Power 2 over square root x power 2 plus 1. Square root limit x power 2 over x power 2 plus 1 x approach to positive infinity equal to square root differentiate numerator to x over 2x limit x approach to positive infinity equal to 1 square root 1 equal to 1. Question number 43. Sine x over x minus pi when x approach to pi. Sine pi, this is the graph of the sine. Sine pi is 0. Then the result is 0 over 0. Therefore, we use L'Hopital rule. Limit x approach to pi, differentiate sine x, cosine x. Differentiate the denominator with respect to x, 1. Then the result is limit cosine x when x approach to pi, cosine pi is negative 1 equal to negative 1. Question number 44. Limit x approach to positive infinity for ln x power 4 over x power 3. Ln infinity is infinity over infinity power 3 infinity. Therefore, we use L'Hopital rule. Limit x approach to positive infinity, differentiate ln x power 4, 4x power 3 over x power 4 over 3x power 2 equal to limit x approach to positive infinity, reduce x power 3 with x power 4, 4 over 3x power 3. Now, substitute every x with infinity, 4 over infinity power 3 infinity times 3 infinity, 4 over infinity equal 0. Question number 47. I skipped number 45, 46 because they are cancelled from the ministry. The last question in this set of questions, 47. The function of velocity of a moving body is v of t equal 30 6 minus t squared minute meter per second, where t between 0 and 6 greater than or equal 0, less than or equal 6. Find the velocity and the acceleration of this body at t equal 3. Then what can you say about the velocity of this body when the acceleration and the velocity are of the opposite sign? As you know, the derivative of the velocity function give you the acceleration function. Then v of 3 equal to 36 minus 3 square equal to 36 minus 9 equal to 27. This is the velocity of this body at t equal 3. To find the acceleration, differentiate the velocity function, then v prime of t with respect to t, it's to negative 2t equal to the acceleration function. Then a of 3 equal to negative 2 times 3 equal to negative 6. This is the acceleration of this body at t equal 3. When the velocity and acceleration are of the opposite sign, it means that the body is slowed down with the time. See you next lesson.